Hi, welcome to the analytics product demo. This product is by Hanaya Incorporation, a subsidiary of Visionsoft Incorporation. In this particular product, we have three use cases that we are trying to target in the current scenario, which is predicting inventory optimization, which as you can see is open right now. The second use case is revenue demand forecasting, and the third one is predicting equipment failure. So these are the three use cases we have right now. So to start off, I'll start off with the predicting inventory optimization use case. So before I try to go through the particular model or the solution we have right now, I'll just run it and then get to the explanation. So yeah, this particular use case is to resolve inventory optimization challenges by accurately focusing and forecasting demand, thereby balancing stock levels to meet the customer demand without overstocking and tying up capital and storage space. So basically, this use case focuses on optimizing inventory levels by leveraging data-driven demand forecasting. The goal is to maintain an adequate stock to meet the customer demand while minimizing excess inventory. So coming to the methodology that we have implemented right now, as of right now, so this is the data cleaning. So the first step is, of course, the data collection. We have gathered comprehensive data, including product information, warehouse details, stock levels, order history, the shipping information, the consumption rates of the product by customers, and other relevant external factors. And the next step which we have implemented is the data preparation or the cleaning, where we have performed a detailed data cleaning and feature engineering to enhance the data quality and relevance for model training. So then coming to the model building here or the model development, as you can see, we built and trained predictive models using the existing data that we have taken to accurately forecast the inventory demand. Then we applied the trained models on the test data and implemented a workflow to calculate the reorder point for optimal inventory management. The benefits of this use case is multiple, but to mention a few few benefits are optimized inventory levels, which ensures that sufficient levels of stock levels to demand while avoiding necessary or excess inventory, thereby reducing storage costs and freeing up capital. The second key benefit would be reduced risk of stockouts. That is, by predicting demand accurately, the risk of stockouts is minimized, ensuring continuous product availability for customers. The third key benefit is improved operational efficiency, as this streamlines inventory management processes, leading to a better resource allocation and overall operational efficiency. Therefore, by employing this predictive approach to inventory management, businesses can enhance their ability to meet customer demand, reduce holding costs, and improve supply chain efficiency. To show you the output where we have at the end here, so this is the output which we have generated. So as you can see, for each product, we have the total stock at that particular point of time on that date, what's the average consumption of the product. So basing on all these particular key features that affect the product, we have come up with the requirement of safety stock and the point of reorder. So the point of reorder, basically this is to show that in these many days, like in 242 days or 249 days for that particular product, the product should be reordered, and the amount can be of the safety stock. Exactly. So this is how we are trying to approach the solution. The second use case, coming to the second use case, which is the revenue demand forecasting. So again, before going into the workflow, I'll run it. So this particular use case is for enhanced revenue management to address the challenge of revenue demand forecasting through accurate analysis, leveraging AI/ML solutions, enabling businesses to optimize revenue management strategies. This is an important issue to address because Accurate demand forecasting is crucial for effective revenue management. By predicting demand fluctuations, businesses can align their pricing strategies to maximize revenue generation. This use case focuses on forecasting future revenue for various product types and the overall revenue for all products for a customizable period. For in this case, we have taken 21 days. So again, coming back to this particular use case, we have of course gathered the data. The first step is data collection. We have gathered historical data on product sales, shipping details, and supply information and manufacturing costs for various products. Moving on from data collection, then it was on data preparation and cleaning, where we have conducted thorough data cleaning and feature engineering to ensure high quality and relevant data for model training. Following up on this, we have now the model trained here. So developed where we have developed and trained predictive models using the collected data to forecast future revenue for individual product types and the overall product portfolio. And last step of the methodology is the implementation, where we have implemented trained models. As you can see here, for product type, we have taken the complete sum revenue forecast and number of products to be that can be sold for the particular product type. So we have implemented the trained models to predict the revenue for next 21 days with the flexibility to customize the forecasting period based on the user requirement. So as you can see, this is how we have taken up the forecast revenue for 21 days. We also have included the probabilities of high 95, high 80s, low 80 and low 95 predictive values of how the revenue can be for different product types. The benefits of this particular solution that offer to the users are optimized pricing strategies, like enabling businesses to adjust pricing in response to predicted demand, ensuring optimal revenue generation. And the second benefit would be enhanced revenue management, where it provides a clear understanding of future revenue trends, aiding in better financial planning and decision making. The third benefit would be informed inventory and supply chain management, which allows the business to align inventory and supply chain strategies with revenue forecast to meet demand efficiently and cost effectively. Overall, by leveraging AI/ML solutions for revenue demand forecasting, businesses can gain a competitive edge through improved revenue management, optimized pricing strategies, and effective resource allocation. This proactive approach helps in maximizing revenue while maintaining customer satisfaction and operational efficiencies. The third use case is predicting equipment failure. Again, before going through the use case, I will run it. So this particular use case is to predict the likelihood of equipment failure in future cycles, enabling customers to undertake proactive maintenance and ensure equipment reliability and performance. With this use case, we aim to predict whether the equipment will fail in the upcoming cycles, allowing customers to take preemptive measures to maintain their equipment according to the industry standards. So again, for this, the first step is to collect the data, where we have collected historical data on equipment failures across various cycles were gathered. Then, using the trained data, we have trained a model using historical failure data to identify patterns of indicators of potential equipment failures. And then we have used the test data to as an input for the trained model to forecast whether the equipment would fail in the future cycles. The benefits of this particular use case are very high, and more importantly, very important to the customers and the customers. The first benefit is the proactive maintenance, which enables customers to perform maintenance before equipment failure occurs, reducing downtime and maintenance costs. Increased reliability, which will ensure that the equipment operates reliably, enhancing overall operational efficiency. And the last benefit is cost efficiency, where it minimizes unexpected failures and the associated high repair costs by allowing scheduled maintenance. Therefore, this predictive maintenance approach helps in optimizing equipment usage, extending its lifespan, and improving safety and reliability in operations. You can see this is how we have taken. We have a couple of sensors setting different products, the number of cycles that it has been used. Sorry, this is the output data, right? So this is the future cycle that we're trying to predict. These are the settings we have for the test data, the sensor readings, different sensor readings that we have taken, and different columns, different readings. But if you scroll to the last, here we have the probability of failure which we have generated using the data which we have, or using the model which we have trained. Thank you.